this video, we'll continue our discussion of limits in 3 space, given a limit that is in 4 space. So here's our limit. Notice that that this is some kind of function in 4 space, right? The domain is a surface, or surfaces. So geometrically, this is weird, but we can do it algebraically. Okay, so let's start with the axis first. So along the x-axis, okay, remember that is y equals 0 and z equals 0. All right, so that's going to be our first path. So the limit as, okay, we just keep our x goes to 0. And then we can go ahead and let the y's and z's go to 0. So x times 0 squared plus 2 times 0 squared over x squared plus 2 times 0 squared plus 0 to the 4th. Okay, we get the limit as x approaches 0 of 0 over x squared, which is the limit as x approaches 0 of 0, which is 0. Okay. So that's one path. The next path that we're going to try, we're going to create a path. So we'll call it a long C, and then we'll go ahead and define what C is. Right? Again, I'm looking at my denominator, and I'm trying to match things. Remember, we're going to call x something of t, y something of t, and z something of t. I see that z has to the 4th power, so it'd be nice if I could turn these to the 4th power. So what that means is, okay, so I have x equals, y equals, and z equals. I'm just going to let z equal t. So when I plug in t into this up here, I get t to the 4th. So I'm trying to get t to the 4th on the other ones, which means they would need to be t squared because I'm going to square them. All right, so there's my path. All I did is try to create my denominator, make my denominator end up be able to add all my terms up. So I've made them all become t to the 4th. All right, so let's plug all that in. The t is still going to 0, right? If we look at all of these, as t goes to 0, x, y, and z go to 0, so we're good there. And then now I'm going to go through and replace. On the bottom, I'm going to have t to the 4th plus 2t to the 4th plus t to the 4th. On top, okay, I'm going to have t squared times t squared plus 2 times t squared squared. All right, so we get the limit as t goes to 0. All right, and as you notice, I get t to the 4th plus 2t to the 4th. So I get 5t to the 4th on top. And then on the bottom, I got 4t to the 4th. All right, let's make sure that's right. Oh, I messed up. I can't add, I guess. This is 1, then I got 2, so this is 3t to the that, and then this is 4. I don't know where I was getting my numbers. All right, so I'm glad I caught it, though. Okay, the limit as t approaches 0 of 3/4, which is 3/4. We have shown that the limit doesn't exist, right? 0 does not equal 3/4. So since 0 does not equal 3/4, the limit does not exist. So the trick here was, again, to match the denominator, but I just have to get a little, they're not going to be all the same this time, right? I'm just trying to get all the numbers in the denominator the same, the variables, that way I can add them together to one term. That's the whole trick.